The objective of this lesson is to have students be able to organize data into a scaled pictograph. In the previous lesson, students learned about creating and interpreting bar graphs. In this lesson, students will see that bar graphs are not the only type of graph that can be scaled. Pictographs may also be scaled. Let's look at a new type of graph called a pictograph. How is this like a bar graph, and how is it different from a bar graph? Just like a bar graph represents data, so does a pictograph in a slightly different way. Pictographs visually represent information using pictures rather than bars. Each picture represents how much of something belongs in a category. As you see in this example, a pictograph has a title, in this case, Items Sold at the Snack Shack. It has pictures and categories. Here we have chips, chocolate, and candy, and it has a key which tells you the number each picture represents. One misunderstanding with pictographs is forgetting to look at the key and just counting the pictures. But just like bar graphs can be scaled, so can pictographs. Looking at our pictograph or picture graph, how much does each picture represent? The key tells us that each picture represents 10 items sold. Just like bar graphs, if there are large numbers used in the data, the graph would be too large and probably difficult to read. So this graph used a scale of 10. What does the half chips bag and half candy bar represent? If each picture represents 10, then half must be 5. So how many total items were sold at the snack shack? How many chips were sold? If each bag represents 10, then it looks like 10, 20, 30, 40, 50 plus 5 equals 55 bags of chips. How many chocolate items? If each candy bar represents 10, then there were 10, 20, 30, and half of 10, or 5, which equals 35 chocolate items. How many candy items? This one is easy. 10, 20, 30, 40 pieces of candy. What is the difference between the number of chips sold and the number of pieces of candy? If there were 55 bags of chips sold and 40 pieces of candy, then 55 subtract 40 equals 15. There were 15 more bags of chips sold than pieces of candy. Teachers then ask students to create their own pictograph by thinking of a subject or title and collecting the data. They remind students to choose the appropriate scale for their data and then create their own pictograph, including a key, categories, and pictures. For students needing a challenge, they are asked to write an equation for each category in the pictograph. Using our snack shack graph, they could write 10 times 5 equals 50 plus 5, which equals 55 for the chips, or 10 times 4 equals 40 for the candy. In this lesson, students organize data into a scaled pictograph. We accomplish this by having students learn about pictographs and then creating one from data they collect.